Good. Good. Yeah. Anyway, that's kind of lame. Anyway, all right, let's take a look.
Wait, where are we at?
Okay, this is going to be example 3. If you're looking at slides, it's slide number 9. So if you're counting slides, it's actually slide number, it's like the 7th one down or something like that. Anyway, so it's the start of example 3. Okay, this is exactly the same as what we've done before. Okay, if you do it this way, it works out the same all the time. You don't need a new way to do any of these. I'm not going to show you identities for this. Every time we're actually trying to do this, you have your X, Y, and R. X, Y, and R. So now we have 2 different angles. We have an angle S. Okay, we have an angle S that we're using, and then we're going to find the half angles for cosine, sine, and tan. Okay, so right now we start off with cosine, so I need to find the other side. So cosine, we know cosine is what over what? X over R. In this case, it's X over R, right? It's not an identity. Identity is just X over 1 because my radius is 1 in an identity. But for regular, it's going to be X over R. So now for this case right here, I know that I did not touch the pen. All right, so there we go. Let's see. I want this one. All right, so I know that X is 2, R is 3, and Y is, I don't know yet. Now, it says that it is going to be, S is between 3 pi over 2 and 2 pi. What quadrant does that tell me? Do you have a unit circle in front of you? Or is it too much work to find your unit circle?
Yes.
What quadrant? 4. It's quadrant 4, isn't it? Okay, quadrant 4. So I'm going to put a 4 right here. That's my quadrant. There we go. Quadrant 4. So what do I know about quadrant 4? X is positive and Y is negative. So that's going to help me out for here. So for the Y, I need to use my Pythagorean theorem, right?
Yeah.
So it's going to be
2
plus
y squared
equals.
3 squared.
So I get 4 plus
Y squared equals 9 minus
subtract
5. So square root of 5.
plus or minus square root of 5.
And it's going to be negative.
So this one is negative because of the quadrant now, right? Okay, so I have my negative rad 5. Okay. So I'm going to go back and look at my cosine of S over 2. S divided by 2. That's my angle divided by 2. That means it's a half angle. Right? Okay, so the formula for the cosine of S over 2 isn't it like plus or minus square root something? 1 plus cosine, for this case it's S, over 2, like that? Yes? Okay, so this is from your formula page, right? So we're just plugging stuff in now. So cosine of S, so we know that for this one right here, that cosine of S, so here's my S, and then my cosine is going to be this one right here. So it's going to be 2 over 3, isn't it? So 2 over 3. So right here, I'm going to bring this down so it's plus or minus square root of 1 plus my cosine was 2 over 3 over 2, right? Did I lose anyone on that?
Yeah, because I can't see.
Oh my god.
You want to take Zoe's seat? I'm sorry, I am not left-handed, so I try to move this way. I am ambidextrous, but the problem is
Utilize that.
I know.
my penmanship is not as good with my left.
That's how I am with my right.
Okay. So, do you have this now? Hey, do you have this? Okay, good. Equals, plus or minus. Now, I have a fraction over fraction, so I clean that up, and to clean it up, I need to multiply by the Reciprocal with a mouthful of food. Thank you. 1 plus 2 over 3 times 1 over 2. Very good. So again, let's bring it down.
I have a question.
Yes.
Can you do the 1 plus 2 over 3 before you do the reciprocal? Is that okay?
Yes, you can.
Oh, okay.
Yeah. So if I were to do this, what would this be on top? So if I, like, do you guys hear what she said? She said, can I add these together first? Yes. Yes, you can. So we could add those together. Isn't this 3 over 3?
Yeah.
Would it be 5 over 5?
5 over 3. Yes, it would be 5 over 3. So I could do that. Do you want to do that one first?
That's what I've been doing, so I thought
Hey,
I was doing
it's fine.
it wrong.
No, it's fine. The reason why I do this like this step every time is because that this only works when I don't have a radical.
Okay.
So I don't want to show you the way that's not going to work all the time. That way only works when I don't have a radical. Okay, so now for right here, I'm going to distribute. I'm going to distribute so I get 1/2 plus 1. Actually, let's make it 2 over 6. Just for the sake of my fraction. 2 over 6. So I could have canceled it out, couldn't I? If I canceled it out, I would still be left with some issues over here, wouldn't I? I'll still have to have common denominator anyway. So it really doesn't matter. So add those together. I would have common denominator. So this 1/2 would now become what? 3 over 6, wouldn't it?
Yeah.
So 3 over 6. So equals plus or minus square root of 3 over 6 plus 2 over 6, which gives me
5 over 6.
5 over 6. So now this is a whole lot simpler than my other because my other ones always had a radical and I had like a binomial in there. So separate my fraction. So again, bring down my equals plus or minus square root of 5 over square root of 6. Square root of 5 over square root of 6. And then, can I leave it like that? No, I need to rationalize. Multiply top and bottom by rad 6, right? Plus or minus square root of 30 over 6. And I circle that.
So when can't you multiply the radical? That's what I what that part. Because I remember one time you were like, oh no, you can't. Oh, when it's addition. Or
When it's what?
when it's addition, you can't combine them.
You can't, just depends on. So if you have the same radical, so right there, this is a multiplication.
Yeah.
So in a multiplication, you do combine the insides.
Because they both.
Yeah, but if it's addition, they're different. So it's just gonna be this one plus this one.
So if it was like rad 5 plus rad 5, you could combine it to rad 10.
No, it wouldn't be rad 10. How many rad 5s do you have?
Oh, 2.
It would
So
be
it'd
2 rad 5. Yeah, that would be 2 rad 5. Okay, so now that takes care of our cosine. Okay, so I'm going to do the sine. So sine of s over 2. Now, sine of s over 2. Now I got to go to my formula. And it's going to be plus or minus square root of 1 minus cosine s over 2. Okay, this is from your formula. And so now, what is my cosine again? What is it? 2 over 3 again, isn't it? Because it's still cosine, isn't it?
Yeah.
My formula has a cosine of s, so I still use the 2 over 3. So it's going to be plus or minus square root of 1 minus 2 over 3 over 2. Now this time I'm going to combine the numerator first before I actually mess with the denominator. So for the numerator, is this 3 over 3?
Yeah.
Okay, 3 over 3 minus 2 over 3. 1 over 3, very good. So I'm going to have equals plus or minus square root of 1 over 3 divided by 2.
So times 1 over 2.
Okay, so equals plus or minus square root of 1 over 3 times the reciprocal, which is 1 over 2. Equals plus or minus square root of 1 over 6. Now, break it up. Break it up, right? So it's going to become plus or minus I'm not going to rationalize yet. You know, I kind of got ahead of myself. All right, so plus or minus 1, so rad 1 over rad 6. Okay, what's square root of 1? Just 1, right? So the top's fine, right? But I have to rationalize. Multiply top and bottom by rad 6 over rad 6. So that's going to still be my plus or minus square root of 6 over 6.
Yay. Where's Dora to sing for us?
Okay. Last one, tangent.
You could just like not keep
Tangent of s over 2. Do me a favor, a little bit less negativity. So now there's 3 different ones for this one, isn't there? Okay, so I said I always want to avoid which one? Do you remember yesterday when we were talking about it? Avoid the radicals whenever possible. So which one do you think is going to be the least complicated? This one right here, right? Okay, so I'm going to use this one right here. It's going to be the least complicated because I don't have to do much in the denominator. Okay, we now know what sine is because I got that first. So it was it 1, what do we say it was? It is 1 minus cosine A over sine. Cosine S over sine S. So in my case here, it's going to be 1 minus, now cosine of S was 2 over 3, over sine was what? Negative rad 5 over 3. You guys remember? Because sine was the y value, wasn't it? One more. Here it is. Sine was the y value, right? So the y over the r. So I did that at the beginning. So I had this over this. So negative rad 5 over 3. That's my sine value there. So that's where I get that. Okay. So now right here, from this right here, it's going to be 1 minus 2 over 3. We could do that math now, right? So it's 3 over 3. The 1 is 3 over 3, isn't it? 3 over 3 minus 2 over 3 gives me 1 over 3 over negative rad 5 over 3. Multiply by the reciprocal, right? So it's going to be 1/3 times negative 3 over rad 5. What's going to cancel out? 3's. Now I have a positive times a negative, so that gives me a, come on you guys, negative. Very good. So that's going to give me a negative. So I'm going to have a negative, those cancel, 1 over rad 5. Then I have to rationalize from here, right?
Rad 5 over 5.
Rad 5 over 5. So it's going to be, let me see. I'm going to do it right here. Rad 5 over rad 5. So rationalizing is going to give me negative rad 5 over 5. And that one's for my tangent. Now, on these notes, I did all 3 different problems for you. Okay, you're not going to have to do all 3 on every single problem. It's going to ask you for one of those. Okay, I just, my example had 3 different parts, so I just did them all so you could see it all. Okay, so let's take a look at my last one here. There we go, and okay. This one goes along with matching the formula. Which formula is this?
Cosine.
That one's cosine?
Yes.
Okay, so that's cosine of something over 2, right?
Of 12 over 2.
So this is equals cosine of
12x over 2.
12x over 2. Can you simplify this?
Yeah.
So what do I get? Cosine of
6x. And that's it? Yay.
This is like the last one. You match the formula this time to work it backwards. Now I'm not going from the beginning here and plugging in here. So now what does this one right here match?
Tangent.
That's tangent, right? So that's going to be the tangent. Okay, so I would write it as equals tangent of, what is my a value?
5a.
5a, so it's 5a
Over 2.
over 2. And I would just leave it like that. Fractions are your friends. So otherwise it would be like a 2.5a, right? So as a decimal it would be 2.5. But here, I'll circle it. There's your answer.
Yay.
All right. Don't forget, like and subscribe.